And this is inverse matrices and systems. Alright, the first example that we're going to do, I will give you a matrix equation. This is similar to what we just did on the board. And all you're going to have to do is identify which one is the coefficient matrix, which one is the variable matrix, and which one is the constant.
That's it?
That's it in the first example. The variable matrix, that's the easiest, the one with the variables.
Is that going to be on the test?
Yes. You'll have to label them. Well, you're going to have to do more than just label them. You'll have to solve them and label them. And we'll get to solving them in a second. To solve this one, like we just did, this is in the form of matrix A times matrix X equals matrix B. So how would you solve for matrix X?
A inverse B.
A inverse B. Okay? So just make sure right here that you know how to label these. Coefficient matrix, just like coefficients of variables, it's the number in front of the variable. So the coefficient matrix would be the matrix with numbers in front of the variable matrix. Okay, and the constant matrix is the one that's off by itself. Okay? Alright, so the first example, write the system as a matrix equation. Alright, if I give you a system of equations like we did earlier, or last chapter, we have a system of three variables, three equations. We're going to write it as a matrix equation. Alright, the coefficients with A, B, and C are going to form your coefficient matrix. A, B, and C is going to be your variable matrix, and 4, 0, 11 is going to be your constant matrix. So write down this system, and then we'll go straight to the matrix equation. And you want these, just like last chapter, you want these all in standard form, with A, B, and C lining up. That's why we have this little space here and here. A is missing, so leave a space. B is missing, leave a space. Okay. And your matrix equation will look like this. That's it.
Oh, yeah, totally.
All I did was take the coefficients. So it's all we see on the screen right here. The last row is going to be 2, 0, 3. And the middle row, we can see a little bit of it. Coefficients are 1, 1, and negative 1.
Oh.
Okay? The coefficients for the top row, there wasn't an A, so you got to be 0. And you had negative 1 and 2. Your variable matrix is ABC. Your constant matrix is 4, 0, 1. So if I give you a system, you're going to have to be able to put it in matrix form and label the matrices.
You have to solve it now?
Then you will have to solve it. Now this type, you'll have to use your calculator. Because how do you solve any matrix equation of the form AX equals B?
A inverse.
A inverse B. And the only way we can do an inverse of a 3 by 3 is by a calculator. Alright, now a 2 by 2 we can do by hand, and we just did that on the board.
So to find A, you have to do 0 times 1, negative 3, 0, 3.
To find A in this case, we have to use a calculator. Because this involves finding the inverse of a 3 by 3. The only way we can find the inverse of a 3 by 3 is calculator. And I'll show you that in a second. Right here, all I'm wanting you to do in this example is set up a matrix equation.
Okay, so all we're going to have to do is set up. We're not going to have to know how to solve this?
Yes. But we're not going to do that yet. We'll get to that in a second. In this example, we'll just set up the matrix equation. So you're good there, right?
So you just go by the rows for the first one?
Yeah. Okay. Now the next example, here's a 2 by 2. Now the old way of doing this is to either use elimination, graphing, or substitution. I'd probably use elimination here. And you could probably look at that and figure out what y is going to be. But we're going to set up, we're going to solve it differently now. We're going to throw a different method in. We know elimination, we know substitution, we know graphing. Now we're going to solve it by using a matrix equation. Yeah.
Do we have to use a matrix equation to figure out x and y, or can we use?
You can use the old method
Are
if
you
you want.
serious?
Yeah. And I probably would use the old method with these. But I'm just starting out with 2x2s, showing you leading into 3x3s, because you have to use your calculator for a 3x3. Unless you want to use the old method there too. But it's a lot faster using matrices for 3x3s. Here my matrix equation is 2, 3, 1, 2, x, y, 11, 6. Does this make sense?
Yes.
To go from here to here. Now this is in the form of ax equals b. And if it's in the form of ax equals b, you have to do a inverse b. So what we're going to do is find the inverse of a. The inverse of a is 1 over the determinant. Let me scroll back up and make sure we know. Let's see that the determinant is 1. Does everybody see that?
Yes.
Alright, so to find the determinant, I multiply diagonally and subtract. So 2 times 2 is 4, minus 1 times 3 is 3. 4 minus 3 is 1. So don't forget that part when you're finding the inverse. 1 over the determinant. Switch these two. Switch these two. Get 2, 2. Negate these two to get negative 3, negative 1. When I multiply 1 by these, you know 2, negative 3, negative 1, 2. This is the inverse matrix. Okay? Then I'm going to multiply that result by matrix B, which is 11, 6. So when you multiply a 2 by 2 and a 2 by 1, you end up with a 2 by 1. So take the first row or the first column. 2 times 11, 22. Plus negative 3 times 6 is negative 18. So 22 minus 18 is 4. Then the bottom row, negative 1 times 11, negative 11. 2 times 6, 12. Negative 11 plus 12 is 1.
So x is equal 4 and y is equal 1?
X is 4, y is 1. So you can either write your answer as a matrix, or you can write it like we did last chapter, which was 4, 1. Okay?
It takes a lot longer.
Either way. Or you can write x equals 4 and y equals 1. Okay? Yeah, with 2 by 2s, I'd probably just use the old method.
But on the test, we'd have to set it up, and then we could just use the other method. and
Yes.
solve it.
Correct. Now, 3 by 3, 3 by 3, I think is a lot faster to use matrices. So here's my matrix equation. Here's my system. What you could do if you want to use elimination, I'd eliminate the y's. Okay? But if you want to use a matrix, here's your matrix equation. Make sure you understand that before we go on. 2, 1, 3, 5, 1, negative 2, 1, negative 1, negative 9, x, y, z, 1, 8, 5.
And the variable equation or the variables ever going to be negative? Or the variable
No.
matrix?
No, that would get, the coefficient would be negative. The variable is always positive. All right. Now let me show you how to do this on the calculator.
Can you hold on for like 5 seconds?
Yep. All right, so get out your calculator. Alright, so go to second matrix. And we're going to go over to edit. And the first matrix was a 3 by 3. So hit enter. 3 enter, 3 enter, and I believe that's it right there, isn't it? Is that the one I just did?
No.
No?
Yes.
2, 1, 3, 5, 1,
Yes.
negative 2, 1, negative 1, negative 9. Type that in. And then go back and do matrix 2. Matrix 2 was
How
the
do you go
3.
back?
Huh?
How do you go back?
Second flip,
Second matrix,
second flip, yeah.
and then go over to edit. And do 185. I believe I have that in here. Everybody got the first one in? Second one, you would do second matrix, go over to 2, or edit, and down to 2, 3 by 1, 185. Everybody got that so far? Alright, so now all you do, get a blank screen, second quit, then do second matrix, 1, inverse, which is right here, and second matrix 2, enter. There's your answer. So I think doing a 3 by 3 by using matrices is going to be a lot faster than doing elimination, but if you want to use elimination, that's fine with me. Okay?
If we have 3 by 3s, are they always going to be multiplied by 3 by 1s?
Yes.
How many of the problems are going to be non-calculated?
I don't know.
How many
I have to
calculated
get
ones are there
I'll
going to
tell you all that tomorrow. Alright, and the last example we're going to look at is here. I'll give you a system. This is easy. System 2 by 2, and ask you to solve. Here again, if you want to use elimination, that's fine with me. You can use elimination easily. You can probably do that in your head. Because the y's eliminate, you're left 2x equals 10. So what's x? 5. So what would y be? Negative 2?
Yep.
Okay. So y would have to be negative 2. But this is how you do it by hand using a matrix. You have to do A inverse B again. So it's probably a lot faster in this case to just do it the old way. Alright?
But we still have to show you the steps in the test, right?
You would have to show me the steps, whatever method you chose to use.
Oh, so
You don't have to use a matrix.
Oh,
Yes.
Did you write that?
Emily did.
Let's see what we're asking here. This is asking if there's a unique solution. That's what it is. You know that there's a unique solution because of what we just said, using elimination, or by finding the determinant of the matrix. If the determinant of the matrix is 0, then there is not a unique solution because you can't divide a number by 0. Okay? So since my determinant of this matrix came out to be negative 2, then it does have a unique solution. It has a solution. Otherwise, it would not. So my next one,
What a waste of calculation.
my next one would not have a unique solution, just because once you put in a matrix equation, you find the determinant to be 0, it does not have a unique solution. Okay?